Good day, Ma'am Basilio. We are BScs2B for the course Operating System presenting our midterm project, the scheduling algorithm of highest response ratio next, or HRRN, known for short. This is our team. Hi, I'm Benedict.
Hi, I'm Paula.
Hello, I'm Adler.
Hi, I'm Yasmin.
So, highest response ratio next.
Highest Response Ratio Next, or HRRN, is a scheduling program, non-preemptive CPU scheduling algorithm designed to be an improvement on the shortest job next algorithm. While SJN prioritizes the process with the shortest burst time, which can lead to starvation for longer processes, HRRN introduces a dynamic priority system that helps prevent this.
Now, moving on to what makes HRRN unique. First, it is non-preemptive because once a process is selected and begins execution, it runs into completion without interruption. Its next characteristic is balancing act. The algorithm strikes a balance between favoring short jobs, like SJN, and preventing a starvation for long jobs. Next is the starvation prevention. As a process's waiting time increases, its response ratio also increases. This ensures that even long-running processes will eventually gain a high enough priority to be selected for execution. And lastly, dynamic priority. The priority of a process isn't fixed. It changes over time as its waiting time changes.
Now, let's discuss how HRN works. The core of the HRN algorithm is the response ratio, which is calculated for each process in the ready queue. The process with the highest response ratio is chosen to be executed next. The formula for the response ratio is response ratio equals waiting time plus burst time divided by burst time.
Nextly, we will present our codes. The code is divided into four snippets. Part 1, which discusses its process class. Part 2, which will discuss its input handling. Part 3, which will discuss its scheduling logic. And Part 4, which is the results and Gantt chart. Let's start at Part 1. Simply, a process has many variables such as its process number, its arrival time, its burst time, waiting time, turnaround time, if it's completed, start time, finish time, response ratio. This is the most important variable. Then we will make public process, which will take in the parameter process number, arrival time, first time as integers. And as set as default, it will be set as 0 and its completion as false. Next.
The next part is the second part. For my part, I will explain the input and validation section. Here, the program first asks the user how many processes they want to schedule and only allows values between 1 and 6 to keep the program manageable. Then, for each process, the program requests two inputs, the arrival time and the burst time. The program also checks if the inputs are valid. For example, burst time cannot be 0 or negative, and the arrival time cannot be negative. If any invalid input is detected, the program will stop to avoid errors. And finally, all the valid processes are added to a list, which will later be used in the scheduling algorithm. Now, moving on to part 3.
Next, I'll explain the logic or the core of the program, which is the highest response ratio next scheduling algorithm. Here we can see that there is a while loop that runs until all processes are completed. The program simulates CPU time step by step. So at each point in time, it checks which process have arrived and it places them in a ready queue. However, if the CPU is idle, meaning no processes are ready, the program simply advances the clock to the next arrival time. Next slide, please. Next, for every process in the ready queue, the, the program calculates the response ratios. Using the formula, response ratio equals waiting time plus burst time divided by burst time. The process with the highest response ratio is then executed next. And when a process is executed, its start time, end time, waiting time, and turnaround time are all updated, and it is marked as completed. The loop continues until all processes have been scheduled. So in short, this part of the program decides which process should run next depending on their response ratios. Next, for the results and Gantt chart, let's hear from Paula.
Thank you, Yas. Finally, I'll explain the results section of the program. After scheduling is done, the program prints a results table. This table shows each process along with its arrival time, burst time, waiting time, turnaround time, and response ratio. It also calculates and displays the average waiting time and average turnaround time to give an overall measure of performance. The program then constructs and displays a Gantt chart which visually represents the execution order of processes over time. The Gantt chart shows the processes in sequence, their start and finish times, and includes the label HRRN to indicate the scheduling method used. This makes it easy to understand how the CPU time was distributed among the processes.
So now, so now let's go to the code execution. So here's the code program in Java. We use the editor VS Code and we will start the test case 1. Test case 1. The number of processes are more than 6 or less than 1 as discussed earlier by Atler. Running the program, it asks how many processes will be entered. Let's try entering 0, which is an invalid amount of processes. It will return invalid number of processes, and it exits the program. Next, let's try 6. 6 more than 6. It again says it's an invalid number of processes because the code was made for 6 processes only. Let's now try another test case. The input values for burst time or arrival time is not a numerical number or valid. Say we put a valid amount of processes, number 5, and we put an invalid number or an invalid character for the arrival time. Say the letter A, it says invalid input, and it exits the program. And finally, the test case 3, which is no error. We will use a good amount of processes and using the right inputs. We have example 1. This table shows a given arrival time and burst time for 5 processes. Let's start the program. For the first process, it's 0 as the arrival time, 9 for the first time, 2 for the arrival time of process 2, 6 as the burst time of process 2. For process 3, we will enter 4 as the arrival time, 5 as the burst time, process 4, 5 as arrival, the burst time of 3. And finally, the process 5, which uses 8 and 7. Let's see the output in detail. It takes in the input of arrival time and burst time for each processes and provides a step-by-step computation. It also shows the original arrival and burst time, the waiting time, turnaround time, and its response ratios in two decimal places and provides how many seconds it took for each process on the average waiting time and average turnaround time. The Gantt chart also shows which algorithm was used, which is HRRN. It also provides a timestamp for each process when it started and when it finished. So we can see that process 1 was the first to pick, as it was the first to arrive. Then process 4, as we can see here in the decision making of the algorithm. It always chooses the highest response ratio. Then the next process will be process 2, process 3, and then process 5 finally, as shown in the final Gantt chart. That will be all for our presentation on the highest response ratio next algorithm for operating system. Thank you and have a good day, Mom Stephanie Rose Basilio.